Hello and welcome to the continuation of the unit version control systems. So here we'll continue on discussing the different types of VCS. So here we have your distributed VCS. So, so with distributed VCS, as the name suggests, distributed din siya ang repository. So wala siya ga-exist on wala siya ga-exist on only one PC or computer but on other computers as well or other workstations. So, typically ara sila the developer may ara sila nga local repository dira. Each user has their own repository and working copy. So if you want to commit, di ba, kung mag-commit ka mo sa changes, so ma-update lang to the the local repository lang. But if you want to to update your the other repositories sa other PCs, so you need to do some other functions. So nagdugang ka lang ng steps. So here is an diagram of what a distributed VCS looks like. So here, mayroon ka mo sa server computer, so mayroon tasang repository dire, mayroon makita repository sa computer A, and then sa computer B. Then whenever ako be sa computer A, so whenever I update the code, so I am doing the change or I am committing the change on my local na repository. Then sa computer B, so haraman siya. Then when we want to make this repository, to make the server repository copy the repository on my end, on my local computer, so I need to do some things. So I will explain that later on. Manotice nyo din with this type of system of VCS, so whenever the server computer is down, so you can also continue working on committing, updating the other repositories of other workstation. Okay, in each na workstation or each na PC may ara ka mo sang local na repository. So this does not hinder the progress of your development. So this is so the things or the functions or the commands that we do, so whenever we want to make our changes visible to others. So let's say I am on PC1. So if I want my changes, di ba, on my working copy to be visible on PC2 and on PC3, so I need to do the following. First, di ba, if makommit na ako sa repository, but in this case, I am committing on the local repository. So after that, after nga nakakommit na ko sa local repository, so I need to push these changes on my repository to this repository that is on the server or the remote repository. So what will I do is do a push command. So this pushes the changes or the new state of the repository to the remote repository. Then the third one, so if they see PC2 and then see PC3, so they want the repository to fetch the changes that I've made. So i-call nila ang pull na command. So i-pull nila ang updates. So from the remote repository nga gi-update ko. Then once nga ara na sa ilang local repository, so they will just call the update function para mag-update ilang working copy. Kay diba sa working copy na sila edit or code. So that is for your distributed version control. So more steps man. But this ensures that so fail safe ni siya. So meaning whenever there is power outages or data corruption on one or two na pieces, so may ara pa ka mo remaining repositories. So makakontinue pa na ka mo. Okay, so here are some of the keywords that you will be encountering when you are talking about version systems. So first is commit. So when we say commit, so this is applying the changes made to the local or distributed repository. So here ang istorya na to kay local. So ga-commit kita sa changes from the working copy to the local na repository. And then next is tag. So si tag na siya, associated na siya on the software versioning. So with tags, so this assigns a meaningful name to the specific version in the repository. So sa changes mo dira, diba? Sa changing in lista, so pwede na kamo kabutang kang tag. So this tag, so this will signify that this is a specific version of your application. So tags are very similar to branches, but the difference is that tags are immutable. So later on, we will discuss what is branches here. And then, remember that tags are immutable. So meaning, once nga maset na siya, so maset mo na kung din na siya, hindi mo na siya ma-change. Hindi mo na ma-change ang number, hindi mo na ma-change ang value. So here we have two functions, two actions in Obrata. So we have the push and pull. So na-notice nyo man ito ba sa distributed na VCS. So when we say push, so this refers to pushing the changes made from a local repository to the remote repository. So gina-push ta ang changes ta from our local repository to the remote repository. Then pull is the action to fetch all of the changes made from the remote repository to the cloned local repository. Then next is we have your branch. You see branch. So these are used to create another line of development. So usually a branch is created to work on a new feature. So when you say branch, so ga-branch out. So balaan nyo na ang branch, diba, sang kahoy. So let's say ang main branch, that represents the main nga repository of your application. So if you want to work on a specific feature, so you can create a new branch. So a new branch na ma-branch out na siya. Meaning, ang copy, so i-copy yan na ang contents ng main nga branch. So main nga branch meaning ang main nga contents sa inyong repository. Para sumakit niya sa new branch. So let's do So this is the main branch. And then, so this contains all of your codes or files sa project. Then when we say kung mag-branch create sa new branch, so this will create a new branch right here. This one. So this is let's say this is your main branch, and this is your branch 1. So with branch 1, so whenever you create, so dire na kamo whenever you are updating the code, you are adding a new feature specifically, so dire na sa branch 1 nga code nga working copy ga-update. So wala na kamo ga-update dire. So ang inyong update, so dire sa branch 1 kasulod. So why? Nga akin lang ni siya. Okay? Para hindi ta ni siya matandog ang aton nga main branch. Hindi na siya matandog, so whenever we're trying to create a code then, or trying to create a function, or code, so sometimes may mga error na siya. So whenever that error occurs in your code, so ang branch 1 lang ang maapektuhan. Ang main branch ta is unaffected siya. And as well, ang purpose na siyang branching is that other developers can create their own branches. So pwede na siya ka-create B2, and pwede man siya ka-create ka B3 dire, and so on and so forth. So may different working copies sila nga ma-access. And at the same time, ang inyong working, so ang main yung get, so gina-assume ta nga si ang main branch na dire sa inyong repository is the working nga codes. So here, so hindi na kamo marisgo nga maguba ang main yung code. And then, next is your merge. So, related din siya on creating a branch. Diba? Kung ga-branch kita is ga-branch out. So, if, for example, branch 1, kung pag-develop in terms of development, okay na. So, okay na ang function, okay naman ang mga bugs na-fix na. So, it is time to merge the changes made from branch 1 to the parent branch. So, in this case, si main branch. Okay? Kung di man na siya nag-branch out si branch 1. So, when merging, so mabalik siya to sa original na branch. So, ang current state, so once ma-merge ang current state ni main branch, is this one plus, plus B1. Nasuma plus B1. Madako ng contents ang ato ni main. So, that is when we say, ga-merge kita ang branch. Next is we have clone. Ma-clone kita sa repository. So, the clone operation creates an instance of the repository. So, ga-copy-paste kita sa repository. So, ginakopy to ang remote repository so before ta mag-work, diba? Before ta mag-access ang atong nga working copy, so you need to create or you need to have a local na repository. The clone operation not only checks out the working copy but also mirrors the complete repository. So, complete na siya. One by one din siya nga copy-paste. The user can perform many operations with this local repository. So, that becomes a local repository. So, pwede na kamo kasad sang development. So, here we'll discuss the importance of VCS. So, with version control, so they help teams solve these kinds of problems, tracking every individual change by each contributor and helping prevent concurrent work from conflicting. So, with VCS, diba, sumatrack nyo na siyang every changes nga ginaobra. So, ginaobra mo, ginobra sang upod mo, ginobra sang iba nga developers. So, kung developers man so from different time zones, different countries, sumatrack na sang VCS. Also, ma-prevent na siya sang conflicts with your development. So, when we see conflict, so, for example, ang code so, ang line of code na gina-modify mo are the same, are almost the same, or ara sa scope sa code naging modify sa upload mo. So, with that, ma-conflict na siya So, kay CVCS, ma-detect yan na. So, whenever you're committing the change, ma-commit mo siya sa change, so, na siya, ma-clash na ang changes nyo. So, you need to resolve that. So, with VCS, may way na kamo para ma-resolve. So, changes made into one part of the software can be incompatible with those made by another developer working at the same time. So, with concurrent na work, so may aragyan mo cases nga ginobra mo is incompatible na siya with the work of your teammates. So, these problems should be discovered and solved in an orderly manner without blocking the work of the rest of the team. So, with VCS, ma-enable na siya. So, further, in all software development, any change can introduce new bugs on its own, and new software can be trusted until it's tested. So, testing and development proceed together until a new version is ready. Sabi na siya, with branching, di ba? So, maka-create na kamo or ma-specify nyo or ma-isolate nyo ang code for that specific na feature lang. So, hapos na siya i-test, di ba? Hapos na siya i-develop. Here are the different importance, different reasons on why VCS is important. So, with VCS, so mayara ka mo sa complete long-term change history of every file. When I say every file na ara sa repository, matrack sa VCS. This means that every change made by many individuals over the year. So, kung 1990s pa man to, or 2000s, until now, so as long as may VCS at that time, diba? And then they are starting to update the repository over and over again. The such time na i-try mo access, so mayara ka mo long history on what happened to that repository. The changes include the creation and deletion of files as well as edit to the content. So, any modifications on that repository, so matrack sang VCS. So different VCS tools differ on how well they handle renaming and moving of files. This history should also include the author, the date, and written notes on the purpose of each change. So with, di ba, sa changes, so hindi lang dapat yan may specify o yung mabalaan mo ang changes ng file, but also ang timestamp, kung saan naman naging change, and then ang author. So author can be your email, can be your name, etc. And then the notes. So with notes or messages, so that that gives the developers or others man a window or an idea on what happened on this change or on these commits. So having the complete history enables going back to previous versions to help in root cause analysis for bugs, and it is crucial when needing to fix problems in other versions of software. So if the software is being actively worked on, almost everything can be considered as an older version of the software. So pwede na kamo ka-backtrack. Pwede nyo na siya ma-check ang life cycle or ang evolution sa application nga na, sa mga bug fixes nga natabo, sa mga features nga ni-implement, and so on and so forth. So another reason is that you can do branching and merging. So discuss naman na siya ang purpose, di ba? On how branch and merging works. So when we create a branch, is in this CS tools, so this keeps multiple streams of work, so multiple copies of work. So in each copy, in each branch, so pwede na kamo ka-work simultaneously. So depende man na sa pila ka developers nila. So independent from each other while also providing the facility to merge that work back together. So whenever you're done working on the feature or on that branch, you emerge back yun na siya sa original branch. So enabling developers to verify that changes on each branch do not conflict. So with many software teams adopting the practice of branching for each feature or perhaps branching for each release or both. And then last na reason why we have version control systems is that we have traceability. So being able to trace each change made to the software and connect it to the project management and bug tracking software, and being able to annotate each change with a message describing the purpose and intent of the change can help not only with the root cause analysis, but also other forensic. Kung matrace nyo na siya so mabalaan nyo na ang evolution sa as well, di ba, bug fixes. So mabalaan nyo na that na-fix na ang this particular bug over a specific na commit, di ba? Na-implement nyo na ang specific features or this new feature right here. And then with messages that accompany each commit, dumay na siya. Overall, dumay documentation na kamo sa inyong application. So having the annotated history of the code at your fingertips when you are reading the code, so trying to understand what it is doing and why is it designed can enable developers to make the correct and harmonious changes that are in accord with the intended long-term design of the system. So makabuli na siya sa developers. So when they are checking the logs or changes nga na-commit sa iba na developers. Tapos na nila mag-guess kung what are the features man din nga alubrahon, may mga bug fixes nga need pa alubrahon. This can be especially important for working effectively with legacy code and is crucial in enabling developers to estimate future work with any accuracy. Muna siya kung inyo dang application, so all the applications that exist before 5 or 10 years man be, so as long as may DCS sila, include, so hapos na kamo makakip up sa current na changes. So that's it for the video lecture of version control system. So I hope you've learned something. So thank you for watching and see you on the next one.